In the next video, we're going to discuss the angle addition postulate. If you understood the segment addition postulate, it's pretty much the same thing, except for this just deals with angles. Okay, here's what the actual angle addition postulate says. And if you don't remember the segment, let me remind you. If you don't remember the segment addition postulate, pretty much says if the distance from here to here is 3, the distance from here to here is 4, then the whole distance would be 7. You just add the two together. Angle addition postulate works the same way. It says if this point D is in the interior of this angle. Now, what does that mean? The same thing is with the segment addition postulate said if this point right here is between these other 2 points. Okay, this is kind of saying the same thing. So if point D is on the interior, then this angle, ABD, the measure of angle ABD, when added to the measure of angle DBC, will equal, okay, if I add this measurement onto this measurement, what's that mean? So I open the door and then I open it a little bit further. Well, then how far did I open it? This far. It will equal the measure of angle ABC. This angle plus this angle will equal the whole angle. That's all this angle addition, just like the segment addition postulate. So, examples. Use the diagram below to answer questions 1 and 2. Let's zoom in just a little bit. The measure of ABD is 48. So let's find ABD 48 degrees. So what does that mean? You started here, you opened your door 48 degrees. DBC is 78 degrees. So you opened your door further. Let me move that so I can say that I opened it from here to here 78 more degrees. So you opened it 48, then you opened it 78 more. Then how many did you open it? You'll simply do 48 degrees, 48 degrees plus 78 degrees will tell you the measure of the big angle, which is what you're looking for. And that will be 126 degrees. If the small one's 48, the next one's 78, then the whole thing would be 126. Next problem. Says the measure of DBC, which is DBC, is 74 degrees. The measure of ABC, and I'm going to put that down here, is 119. The reason I'm putting it here is because ABC is actually the whole thing, A to B to C. So if I start down here and I start drawing it this way, you open it 74 and then you opened it some more. We don't know how much more. That's what we're trying to figure out. But we do know that the whole thing is 119 degrees. So 74 plus some more is equal to 119. And if you need that as an equation, 74 plus some more is equal to 119. Or you're simply doing 119, take away the 74, you're going to get 45 degrees, which is going to be the measure of ABD. Now let's apply the algebra the same way we did the segment addition. When you add an angle to the angle here that's next to it, called adjacent angles, when you take 13x plus 4 and 10x minus 1, and you add the two together, it will equal the whole measurement, or PQR. And they tell you PQR is 141. Solve the equation, you can figure out what x is. And once you figure out what x is, the same way we did before, we can plug it in, and that tells us how big each angle is. Combine any like terms. 13 and 10 gives me 23 x's. A positive 4 and a negative 1 gives me a positive 3. Bring down 141. Now solve the equation by, let's move the 3 over. Plus 3 is now minus 3. 23x is 138. Divide by 23, and you'll find out that x is 6. But look what they ask you for. Find each measure. Now that you know that x is 6, everywhere you've got an x, you put 6. So this is no longer 13 times x, it is 13 times 6 plus 4. That'll be 78 plus 4, which is a total of 82 degrees. That's this angle. 10 times x is now 10 times 6, which is 60 minus 1, which gives you 59 degrees. Now, how can we see if we're right? This is 82, this is 59. Add those together, guess what you get? 141. So we know we're right. So x here is 6. Measure of PQS, P to Q to S is 82 degrees. SQR would be 59 degrees. And again, you can add those together and you get your 141. Okay, DEF. D to E to F. That's the whole thing. DEF is 7x plus 4. DEG, D to E to G. Now that's this angle. Is 5x plus 1. And finally, GEF, G to E to F, this angle is 23 degrees. So if you add 5x plus 1 and 23, that's the two smaller angles. When you add them together, it's going to have to equal the whole angle, which we said was 7x plus 4. Do your algebra, combine any like terms. 5x has no like terms, but plus 1 and plus 23 goes together. Bring down your equal sign. Nothing combines on the right side. Put your x's on the same side, so let's minus 5x. Put your numbers on the other side, subtract 4. Gives you 20 is equal to 2x, divide by 2, and you get 10. So now everywhere you have an x, you can put a 10. Let's write it above it here. So this is now 7 times 10, which is 70 plus 4. That'd be 74 degrees. So let's write x is 10. Let's see, what was that? DEF. DEF was 74. DEG was, again, x is 10, so that's 5 times 10 plus 1. That's 50 plus 1, which is 51 degrees. And you can check, if you take 74 minus 51, you get 23. So that does check out. Okay, next one, JKM. J to K to M is a 43-degree angle. MKL, M to K to L is 8x minus 20. JKL, that's J to K to L, that's the whole thing, is 10x minus 11. Now again, we know if you add this angle, 43, and this angle, 8x minus 20, when you add them together, it will equal the whole thing, which we said was 10x minus 11. Just like the segment addition postulate. Combine like terms. 8x has no like terms, leave it. 43 minus 20 is a positive 23. Bring down 10x because there's no like terms. Bring down 11 because there's no like terms. Move all your x's to the same side. I'm going to do minus 8x. If I put my x's to the right, I'm going to move my 11 to the left, so plus 11. Gives me 34 is equal to 2x. When you divide by 2, you find out that x is 17. So x is 17. So MKL is now 8 times 17 minus 20. That's 136 minus 20, which is 116. So that was MKL's 116 degrees. JKL is 10 times 17, which is 170 minus 11. It's going to be 159 degrees. Now, how can we check that? This one's 43. So here's 43. This is 116. If you add 43 and 116, you get 159. It checks out. Number 6, DEF is a straight angle. Notice here this is a straight angle. Since it's a straight angle, this has to be 180 degrees. So it says that DEG, D to E to G, is 23x minus 3. It says that GEF is 12x plus 8. But that's all the measurements they give us. But they said this is a straight angle, which means these two angles together have to be 180 degrees because you open the door, open it some more. So that means that 23x minus 3 and 12x plus 8. When you open it this much, then you open it this much more, then you opened it a total at it of 180 degrees. Combine like terms, that's 35x. Combine like terms, that's plus 5 equals 180. Move plus 5 by doing minus 5 to get it away from your x's. 35x is 175. When you divide by 35, you get that x is 5. Let's plug it in and find out. 23 times 5, that's 115. When you take 3 from that, it gives you 112 degrees. There's one angle. 12 times 5, that's 60. When you add 8 to it, that gives you 68 degrees. If you add 112, which is this angle, 68, which is this angle, you get 180 degrees. So x was 5. DEG was 112. GEF was 68. DEF, that was your straight line, was 180 degrees. Number 7, TUW. TUW is 5x plus 3. WUV. WUV, this one is 10x minus 5. That's a horrible x. And then TUV, which is the whole thing, I'm going to write it over here, is 17x minus 16. Again, angle addition postulate. Take your two small angles, 5x plus 3 and 10x minus 5. If you were to add those two small angles together, it will equal the big angle, the whole angle, which is 17x minus 16. Solve the equation. You've got all your information. Combine your x's. That's 15 x's. Positive 3, negative 5 is a negative 2. Bring down these. They have no like terms. Move your x's to the same side. And again, I keep moving them to the right, but it doesn't matter. I just try to keep them positive if I can. Move your numbers to the left. Gives me 14 equals 2x. When you divide by 2, it gives you x is 7. So x is 7. Let's plug all those 7s in. If x is 7, that would be 5 times 7. 35 plus 3 is 38 degrees. This would be 10 times 7, or 70, minus 5, which is 65 degrees. 10 times 7, 70 minus 5 is 65, yeah. This would be 17 times 7, which is 119, minus 16, which is 103 degrees. So TUW, and we'll check it in just a second, TUW would be 38 degrees. That would be TUW. WUV is 65 degrees. TUV, the whole angle, is 108. Check that. If you add 65 and 38, it gives you, or that's 103, excuse me. When you add 65 and 38, it gives you 103 degrees, so it has to be right. Number 8. The measure of ECD is 6 less than 5 times the measure of BCE. Well, unfortunately, we don't know how big BCE is. Okay, so what we're going to do, since they're saying that ECD is all this stuff compared to BCE, I'm going to say that measure of angle BCE, I don't know what it is. Okay, so ECD is equal to, that's not what to write. Measure of ECD is 5 times that, well, what is BCE? X. So 5 times X. And then 6 less than that. How do you find 6 less than something? Well, you take 6 away from it. So therefore, if BCE is X, it says that ECD is 6 less than 5 times BCE, which again we said was X. So this angle here then would be 5x minus 6. So let's label that. And I'll say it again as I'm labeling it. BCE, I don't know how big BEC is. I'm going to put X. ECD, which is this angle, is 6 less than 5 times this angle. So here's 5 times this angle. 6 less than that would be that minus 6. So there's your two angles. The whole angle, BCD, is 162. I'm going to put that 162 right there. Now it's just like the other problems. X and 5x minus 6 are my two angles. When I add them together, it will equal the whole angle, which we know now is 162. Basic equation, combine your x's. That'd be 6x minus 6 is 162. Get your x's on one side and non-x's on the other side. 6x has to be 168. Last step, divide by 6, and you find out that x is going to be 26. So therefore now, let's plug in that for all of our x's. Now it'd be easy to plug it into this one. X is 26. This is 5 times 26, which is 130, minus 6, which is 124. Let's see, 5 times 26 is, let me redo that one. 5 times 26 is 130, minus 6 is 124. Okay, number 8. It says if the measure of ECD is 6 less than 5 times the measure of BCE. Now that's a little confusing now. That doesn't look like the ones we've been working. But now here's what we're going to have to do. It tells you how big this is in comparison to this. However, we don't know how big this is. And you can read the rest of it. It says nothing else about it. Since we don't know how big this is, and this other one's compared to it, we're going to let this be x. Okay? And the other angle is, first off, 6 less than. Let's talk about 6 less than something. If I say, what number is 6 less than 10? And we maybe hopefully remember this from algebra. 6 less than 10 means you're going to take 10. 6 less than that would be 4. So 6 less than means you're going to subtract 6 from it. Okay, 6 less than means minus 6. So what are we subtracting 6 from? 5 times the measure of angle BCE, which is x. So we're going to do 5 times x, 5 times the measure of angle BCE. Then we're going to do 6 less than that. That means 5x minus 6. 5 times x, and then we're going to do 6 less than that, which is 5x minus 6. And that is how big ECD is. So BCE is x, and ECD is 6 less than 5 times x. So let's label that. Here's 5x minus 6, and here is x. Now the whole thing, let me write that above it. 5x minus 6 is that angle, and this angle is simply x. The whole thing, BCD, is 162 degrees. I'm going to put it there. Now it's just like the other problems. When I add my two angles, x and 5x minus 6, when I add them together, I will get the whole thing, which is 162 degrees. Combine like terms, gives you 6x minus 6 is 162. Get your x on one side and everything non-x is on the other side. So let's add 6. I now have 6x is 168. Divide by 6 and you'll find out that x is 28. Now it's easy to plug that in for our first angle. That's x is 28. Now this one is 5 times 28, which is 140. 140 minus 6 is 134, and you can check that. So my three angles are 28, 134, and 162. If you add 28 and 134, you do get that 162. Now the next question is this angle 6 less than 5 times, or excuse me, is this angle 6 less than 5 times this angle? If you do 5 times this, you get 140. 6 less than that, yes, it's 134. So BCE is 28 degrees, and the ECD is 134 degrees. Use the diagram at the left, let me zoom out, to answer questions 9 and 10. So ABF, let me find that. Here's A to B to F. And EBF is E to B to F, which means if I add ABF to EBF, I should get ABE, which is our third angle. So if I add ABF, which is this angle, to plus EBF, which was this angle, then I should get ABE, which is 11x minus 31. So doing the same thing. Combine like terms, 6x, 2x is 8x, positive 26 minus 9 is a positive 17, equals 11x minus 31. Let's move our 8x by subtracting. Let's move minus 31 by adding. 48 is equal to 3x. When you divide by 3, it gives you that x is 16. You can plug it into every one of these to find out if you're correct. Since I'm confident on this one, we don't have to plug it in. We just have to look and see what we're looking for. We're looking for the measure of ABF. So where are we plugging that in? Right here. That's ABF. So therefore, we're going to do 6 times 16 plus 26. That'll be 96 plus 26, which would be 122 degrees. Okay, last problem, number 10. Let me erase this since we're using the same diagram. BD. Okay, let me find BD. Here's BD. BD bisects CBE. And here is CBE. If something bisects, it means it cuts it into two congruent parts. So that tells me that this angle and this angle have to be congruent. And if you'll think ahead, I bet they're about to tell us what this angle and this angle are. CBD, 3x plus 25. That is this angle. DBE, that is this angle, is 7x minus 19. Those two angles, I've already told you, have to be the same. So therefore, 3x plus 25 and 7x minus 19 have to be equal. Now, it gives us a little bit more information, so we might have to do a little bit of extra work, but let's go ahead and find this first. Move the 3x by subtracting. Move minus 19 by adding. 44 equals 4x, so x is 11. So my two angles are 33 and 25, which is a 58-degree angle. 3 times 11 is 33. 33 plus 25 is 58. My other angle, if I did it correct, 7 times 11 is 77 minus 19 is also a 58-degree angle. So let's go back to my drawing. And I believe we're going to have to find some different angles, but I know now that this one is a 58-degree angle and this one is also a 58-degree angle. It says here also that BC and BA are perpendicular. So what does that mean to our problem? Let's see, what do we look for? We look for ABD. ABD. We're looking for this angle. And we also know that BC and BA. Let's find BC, which is this, and BA. They said that they are perpendicular. So therefore, since I'm looking for this angle, I know it would be 90 degrees plus an additional 58 degrees. And when I do that 90 plus 58, I know that my angle that I'm looking for is a 148-degree angle. Again, I use the angle addition postulate. 90 degrees plus 58 degrees is equal to a 148-degree angle.